In example 2.1h, we're going to be looking at the equation y equals x to the 2/3. So this is the third of the example that we're going to see that has a fractional exponent. And this one's one of my favorites because it has a combination of two things. It has a combination of the squaring function as well as the cube root function. So there are two ways to think about this. You can think of it as the cube root of the squaring function, or you can think of it as squaring a cube root function. Since both of those are technically exponent related items, and when you think about your PEMDAS, your order of operations, it doesn't matter which one you do first. You should get the exact same answer, and you will get the exact same answer regardless of which one of these operations you do first, the cube root or the square. And I'll get back to the name of this. I have a special name for this going back to when I was a child in grade school. So let's work on the table aspect of it. After we define this, we'll say f, and because we're dealing with a cube root and a squaring function, which both of them have a domain of all real numbers, this will also have a domain of all real numbers. It takes on properties of both of those functions. And again, that's why it's one of my favorites, because it's a combination of two things we've already seen. And it has the equation f of x equals x to the 2/3. And this is the way that I most often write the equation, as x to the 2/3. But when it comes to your first experience with it, it really is helpful to think of it in one of these two ways right here. And if I was to give you a hint, a suggestion, if you will, I would recommend thinking of it like this. It's going to make your numbers a little bit easier to work with. So let's go ahead and make a table. For the table, I'm going to pick the same values that I would pick with the cube root function. So that'll be -8, -1, 0, 1, and 8. And that's part of the reason why I have this example right after the cube root, because we've just got done using a table like this. So I'm going to make a little section here to the side for some scratch work so you can see how this operation ends up taking place. So I want to take -8 and I want to work with it. So f of -8 is going to be -8 to the 2/3 power. So like I said, we can use this interpretation right up here as a way to help us actually do the calculation. So that's what we'll do. So we're going to think of this as the cube root of -8, and then we're going to take that answer and square it. So the cube root of -8, we saw that on the previous example, that was -2, and then if you square -2, you'll end up with +4. So -8 is going to end up mapping to +4. Now, you can do that same procedure for all of the other x values that you pick. Here's what you'll get. -1 maps to 1, 0 to 0, 1 to 1, and 8 will map to 4. So there's your ordered pair that will help you with graphing the x to the 2/3 equation / function. So let's plot them. 0, 0, 1, 1, and 8, 4. -1, 1, and -8, 4. So like I said, it's supposed to be a combination of the squaring function and the cube root function. So for the first quadrant, I'll have something that looks relatively similar to the cube root function there. And then I'll see a mirror image of that across the y-axis, or the vertical axis. Right here. Let me erase some of these stray marks. And when I look at this, I think about when I was in grade school, and art was not really my favorite thing to deal with, and I think about when I used to be asked to draw a pretty picture. I would do things like this. Here's my clouds, and here's a bird in the sky, and that's how I drew my birds. And every time I see this shape, I think of the birds, and that's why I call this the quote unquote. This is something that only I have come up with that I'm aware of. I haven't seen anybody else call it this. I call this thing the bird function. So if you were to go to a math lab to go get some help, and you tell them I need some help with the bird function, you would need to explain to them what the bird function is. They will have not seen this prior.